Hello, this is Jan, developer of SimpleForest project. So in this tutorial we will learn how we segment trees out of a forest scenery. Um, so the requirements for this processing chain is to have a forest scenery. We can see here colored in white, and already a DTM build, which is also already there. So we will start these steps here. They have been used to build a DTM, and we will start with a step called cut cloud above DTM. So we take the DTM as input. That's why we need the DTM. And our vegetation scenery, which is that name. So we imported the scene. This is a complete forest scenery, and we downscaled it, and of course we will work with the downscaled version. So we will put here 10 centimeters. It is fine. So what it does is it it iterates over each point, and it looks if it is at least 10 centimeters above its ground point raster cell. If yes, then it will put into the upper cloud, otherwise into the lower cloud. So let's run. So the computation did finish. It took 1 minute 30, and let's quickly view the results. So as I said, we have a lower cloud now. This is maximum 10 centimeters above the DTM or the ground points, and the upper cloud. So what we want to get is like a slice in the height where there is still undergrowth. We want to get seed clusters for the following segmentation. So we will cut out a slice between 50 centimeter and 1 meter 50 now. So what we have to do is to repeat the step, cut above the DTM, and we will take the upper cloud. This is what is on the screen. And we will cut in 1 meter 50. Let's run it again. It took 1 minute and 20 seconds. It's just because the cloud is so large. So we took this upper cloud and split into a lower, into an upper, sorry. This is this, and into a lower part. So this lower part, here is 1 meter 50, and here is 10 centimeters. That's the first parameter we gave. But we want to have it from 50 to 1 meter 50. So we will repeat one more time. Cut above the DTM. So we need to we split the upper into lower and upper again. So we have to take this. And I said 50 centimeters. Or let's do 70. So that one was quite fast. Let's look into the result. So we want to get the lower, no, the upper. So, and now we will, try to generate clusters out of it. But we have a problem. All these branches here, they connect the different clusters which with each other. Here, this might everything be a single huge cluster, and but we want to have that each tree is in a different cluster. So what we will do next is a stem filter. So we have to choose the upper here. Wait. Yes, the upper. So the stem filter will compute the principal component. The principal component of a point is perpendicular to the normal, and it shows in the direction. So here, for those points, this little branch, it will just go from this upper left to the lower right, the principal direction for all the points. But for a stem like this, they are aligned upwards, so it will just show in the Z direction. It's like the normal vector, but rather let's stick for the stem, rather showing to the sides like the normal does. The principal component will show upward for those. For the XY plane, it will show either in X or in Y direction, or in between. For this little stem here, it's aligned to the Z-axis, and it will show in the Z-axis. So what we will do is similar to the ground point filter. We have here a few parameters to compute this growth direction. So this is 2 radius. First we downscale to 2 centimeters. Then we build the normal with 5 centimeters. We want to have this number has to be larger than this number. So otherwise the normal computation wouldn't find any neighboring points and couldn't fit a plane to get the normal. And then we compute with this range as soon as we have normals the principal direction. And this again has to be larger than this. So after we have this vector, we just compute like in the ground point filter, the angle between the principal component, or the growth direction, how I call it here, and the Z-axis, and that should not be larger than the threshold given 25 degrees. Here's a degree missing. We will try out. So this is already gone, and that is good. So we wanted to split it. We might want to split it a tiny bit more. Or, well, no, I think it's fine. We will do other filters. So Now it is good to do a statistical outlier filter. And we want to take the stem cloud, and we want to take we want to get rid of all these little points. They are quite isolated. That might be less than 15 points, so we should get a huge distance to the next 50 neighbors, and then the other two parameters we leave unchanged. So let's run. So what do we have? 46 seconds for this huge cloud. We have a filtered cloud. That already is what I wanted to have a bit. And all this little junk is gone. So yes, this is quite nice. So, but we want to remove a tiny bit more. So we will do a radius outlier filter. To get rid of these small clusters, and we take the results of the statistical outlier filter. Five points is not enough. Let's say 15. So each point has to have at least 15 points in a 3 centimeter neighborhood. We want to get rid of all these super tiny clusters. We got rid of part of it, but not enough. So let's say 45. Let's oops. I think this is what we could work with. So you have to try out different parameters, of course. But in the end, the real clustering will come later. So we will do now an Euclidean clustering filter. No, clusterization, segmentation Euclidean clustering, that's what we want to have. So, oops, what do we have to do? So I think input scene group. So we have to give the root group again. This is our input scene, and then we have taken input cloud. This is what we cluster, and the input scene is where we want to put the results. Why do we have another input scene item? We really have. Let's check. No, we have to really give the scene. We shouldn't, but it's fine. So let's give it 5 centimeters. And check the results. Oh, that was fast. So as I put the group as input scene group, we have now here in the group here Euclidean clusters, and we can check the quality by giving distinct colors to each cluster, and then we will see that 5 centimeters was good. Not perfect. No, let's look here. This should be clearly one cluster. And this is also, despite it's the same color, it's also split up. So there might be too many errors. It's nice that those are split, but we have to give it a little bit larger threshold. It was 10. We will try 10 and see if we can get better. So we don't cluster that part, and we have to give new color code. So this is now one cluster, which is nice. This is now one cluster. Do I find and this is still 2 clusters. That's the clusters where I looked into. So it looks good. We have decent seeds, and now we can give use those seeds as seed points for the Dijkstra routine. So that is a step, and so what we want, the seed group with the seed clusters, and as a vegetation we remember that we cut out the vegetation above the ground in the first step of this tutorial, 10 centimeters above. So what and therefore also removed all ground points. That was the first step, so it is this step here, and we want to take the upper. That's our vegetation cloud without ground. And so in case you have a lot of occlusion, you can scale the z-axis of the cloud. So that is that vertical occlusion. If a branch occluded a stem, this is a vertical occlusion, has a less slower gap size. We halve the gap size of vertical occlusion by scaling the z-axis, but the gap size between two neighboring trees remains the same because we all only scale the z-axis. This is this. Then afterwards we downscale to 3 centimeters. Yeah, so for low quality points you would need to increase both values. You can always double, and if this is, look at the results, and if this is not enough, double again. But it should be fine. We downscale to 3 centimeters, and between neighboring points there needs to be 8 centimeter maximum gap. There is barely occlusion here, so 8 centimeters should be fine. Let's run it, and we can always repeat with other parameters. So the computation has been finished. It took 4 minutes, quite fast. If you enlarge the thresholds, then it's even faster, but it might be less accurate. So it just puts the results to this distinct colors. Yes. It takes now a while. So we can see in majority the segmentation looks good. We look here, everything is fine. Also the small trees have been captured quite nice. Yeah, there is still a dead branch. Here the segmentation of the undergrowth is not good, but the trees seem to be fine. So, but there was a fork tree, and this was, do I find it again here? So here we have a failure. So this fork is split into multiple trees. So that is because we cut here, and so this tree will not be really that good. You can, what you would need to do, I don't do it now, is you might want to adjust step by step if you really care about this fork tree. Start from the second cut cloud above the DTM, so make the slice lower, that it's not that the slice is not above the fork. Pay attention to the filterings, and then you might still get also the fork quite good. So we will do we will check now we will blend in the filtered scene. Not this. I didn't want. We want to not have the ground points. So here. So now we see some white points, which are not clustered to any tree, and this seems to be good. But I need to check that we have some white points which might belong to a tree. Not really. So maybe here, this one. Also not really. So let's assume that would not have been captured here, the pink, cause of occlusion. I don't do it because there is no reason to do so, but you have the chance to I just show you the step. Oh, no. So you can you want to select now the Dijkstra as seeds, and then you would again choose the vegetation group as before, so here, and then you could say you can scale again, and you can say align all these white points which have been not clustered yet to its closest cluster, but only if they are less than 77 centimeters away or 10 centimeters. But we don't want to do this now. I just showed you. You have here at this stage the option to do so. Or for reason of completeness, I fill in the step. So again, seed group, this. This has to become the vegetation group, and the upper. So, but as I don't want to really align these parts of trees belonging outside the plot area, I just say here a minimum value of 1 centimeter, and it really should do nothing. And in case I upload the script, you have the step and can enlarge this parameter to make it doing something. So what we still want to do is to classify those clusters. Height-based tree identification from groups. So okay, we have to give a root group. Of course, this is this, and we have to give the input, which is now the Voronoi, It did not do something, this Voronoi, because I just set 1 centimeter as a buffering range, but we will still work with it. And what is missing? The root group was unselected. So what we want to kick out is all things smaller than 2 meter height. So let's quickly do it. So we have split the whole stuff into undergrowth, which is this. And at least here the modeling will fail heavily. It's also not, because of this dead tree, it's not really good segmented. So here you might be able to build some good models, but anyway, what we are more interested is the tree group, that is everything larger than 2 meters. And for the following modeling, we can still, here is a lot of small trees. We want to do the same procedure one more time. So height-based tree identification. This time, so we want to split the tree cloud again into lower and upper, into undergrowth and trees. So this is what we have on the screen, but now with like 6 meters. So everything on the screen is already more than 2 meters. So we will split into 2 to 6 meters and more than 6 meters now. And as we can see, this is 2 to 6 meters. And this is more than 6 meters. So you could split even more if you want to. By the way, this goes out of the cutout input scenery. So if you, well, you should later manually remove it. It will not be a good result. Otherwise, this looks good. So why did I do these last steps? We can choose parameters for the modeling routine. And here's also, is it? No, it's, here is something coming from outside, I would say, wrongly segmented. Or the branch goes here and it's still this good tree, but there is part of the tree missing. Anyway, what I wanted to say is you can choose now for the following QSM modeling for those trees some thresholds, and for the small trees other thresholds, and then the modeling will hopefully become better. Yes. So that is it about segmentation. I would like to thank Tobias Meissner from the University of Leipzig and his according labs for giving me access to this point cloud. This is a segmentation tutorial. See you.